Technology presents educational satellite television programs.
Hello, teacher. Hello, students. Welcome to today's lesson on acid-base indicators. In our last lesson, we learned about the hydrolysis of salts. We learned that salts of strong acids and weak bases produce acidic solutions. We also learned that salts of weak acids and weak bases can produce solutions that are acidic, basic, or neutral, depending on the relative strengths of the acidic cation and the basic anion. We created a concept map to help us remember this information, as well as the information from the previous lesson. Today, we will define an acid-base indicator. We will discuss some different types of acid-base indicators, and we will show their color change in acids or bases. We will also discuss the pH range in which acid-base indicators are effective. Acid-base indicators are weak organic acids or weak organic bases that indicate whether a solution is acidic, basic, or neutral. In order to explain the concept of acid-base indicators, let us consider a weak organic acid that is denoted by HIN. HIN and its conjugate base, IN-, must be different colors in order to be effective indicators. In solution, the acid would ionize, as you see here. If the indicator is in a medium that is sufficiently acidic, according to Le Chatelier's principle, it will shift to the left. When it shifts, the predominant color of the indicator is the non-ionized form, HIN. By contrast, if the indicator is in a medium that is basic, the equilibrium will shift to the right. When it shifts, the color will change to that of the ionized form, IN-. The indicator molecule is a weak acid. Therefore, the ratio of HIN and IN- is governed by the hydronium concentration of the test solution. This equation can be rearranged like so. In order to show how an indicator works, let us consider one that has a yellow color in acid form and a red color in basic form. The indicator dissociation constant is 1.0 times 10 to the power of -6. The color that we see in a solution of this indicator is dependent upon the ratio of acid form to basic form. In a solution that has a pH of 4.0, the hydronium ion concentration is 1 times 10 to the power of -4. This means that the concentration of acid form is 100 times that of the basic form. Therefore, the solution appears yellow. Students, determine the ratio of acid to base in a solution that has a pH of 5, as well as in a solution that has a pH of 6. Would the color of these two solutions be different?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to determine the ratio of each of the solutions? Let us find them together. A solution with a pH of 5 would have a concentration of acid 10 times that of base. However, the color would still appear yellow. A solution with a pH of 6 would have a concentration of acid equal to that of base. This solution would have a different color than the first solution. It would be an orange color. What if the pH was 7? In this case, as you can see, the base is 10 times that of the acid. The solution would be a red color. While indicators are used in laboratories to estimate the pH level of solutions, they are also used to show the equivalent point of titration. Equivalent point is the point at which stoichiometrically equivalent quantities of an acid and a base have been brought together. This image shows some common indicators. It shows their colors in acids and bases, as well as their pH range of color change. Students, look at phenolphthalein. In an acid, it is colorless, and in a base, it is pink. Here, you can see the striking difference in color. Image A is obviously phenolphthalein in a basic solution, and image B is phenolphthalein in an acidic solution. Students, we have time for one last activity. An indicator has an ionization constant that is equal to 1 times 10 to the power of negative 5. If the molecular form of the indicator is yellow and its conjugate base is green, what is the color of a solution containing this indicator when its pH is 3? What if the pH is 5 or 7?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Were you able to determine what color each solution would be? If you said that the solution with the pH of 3 would be yellow, you are correct. The solution with the pH of 5 would be yellowish green, and the solution with the pH of 7 would be green. In this lesson, we defined acid-base indicators. They are weak organic acids or weak organic bases that indicate whether a solution is acidic, basic, or neutral. We also looked at some examples of acid-base indicators and discussed their different color changes. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.